Okay, this is number 10, same section, page 134. So we have a higher order here. We have the order 4 of this homogeneous linear differential equation. So again, let's use the characteristic equation to help us find these roots. So we have 5r to the 4th plus 3, that's not a y, it's an r cubed equals 0. Okay, so can we factor this polynomial? Yes, and the answer is yes, you can factor this polynomial. There is a greatest common factor, right, between these two terms. The greatest common factor is r cubed, right? They have at least 3 factors of r. And what is left over? We have 5r, right? That gives us 5r to the 4th plus 3. Okay, so this guy was factorable. And here we have, right, using this zero factor property, we have r cubed equals 0, right, or 5r plus 3 equals 0. And just solving these equations, right, r is going to be negative 3/5. Okay, so we did get a real root. And let's go ahead and just maybe write that down. So this is a real root, right? No imaginary numbers. So real root. Okay, so what about this guy? Well, r cubed is equal to 0, right? And we know that's just r times r times r. So that means r is going to be 0, right? Because 0 cubed is 0. If you take the cube root, right, of both sides, you'll get 0. But, I mean, this is really saying r is 0. If you write here, r is 0, r is 0. Oh, by the way, and r is 0. Well, this is a repeated root. You're really saying, r1 is, equal to 0, r2 is equal to 0, let's see, r2 is equal to 0, and r3 is equal to 0. Well, I mean, they're really the same, right? Here's the repetition. Here's your repeated root. So here, we're actually going to be using 2 theorems in the book. We're going to be using, let's maybe write that down. So for the repeated root, we're going to be using theorem 2 in your book. This is on page 129. And this guy, well, we know how to write this from 2.2, but it's also emphasized in the book again. And let's see, let me look at the page. It's on this is on page 126. So theorem 1, distinct real roots, page 120. Oh, this is 126. Okay, so let's work on our repeated root. How do we write the solution to this? Well, according to our theorem on page 129, okay, it says if the characteristic equation has a repeated root r of multiplicity k, okay, r multiplicity, right, is going to be that 3, right? So our k is 3, right, that which is called the multiplicity, right, meaning it's just repeated. Okay, so here we're given our solution. So I'm just going ahead and write it out, and then I'm going to insert what we have. So it's C1 plus C2 x plus C3 x squared plus dot 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 plus, and again I'll do this one later, or just right after I finish, because it's not going to fit. Plus ck x to the k minus 1 times e to the rx. Okay, so here, well, what's my k? Well, my k is 3, so if I insert that 3 there, right, well, 3 minus 1 is going to give me 2. So that's how I know I only need this piece. Okay, so I'm just going to go ahead and write that out again. C1 plus C2 x plus C3, right, x squared. And then I'm going to go ahead and write in my e to the rx, but what's my r? What's my repeated root? Whoops. it is 0 times x. Well, again, e to the 0, right? This is just 1. Okay, so 1 times this whole thing is c1 plus c2x plus c3 x squared, right? So that's done, but we still have a distinct root, right? So this is the solution, right, to the repeated roots, or solution maybe, that sounds weird, when we have repeated roots, but we still have our distinct root, right? Our distinct root was negative 3/5. So according to theorem 1, right, or from 2.2, we know the distinct roots on page 126, right, are c1 e to the r1x plus c2 e to the r2x, right, and so forth. Well, there's only one distinct root here, so this is just going to be, well, c1, c2, c3, so in this case it'll be c4. There's 4 roots, and it's going to be e to the rx, and what's my r? My r was negative 3/5 x. So here, again, I'm using 2 theorems, and this is my final answer. So again, that was number 10. Hopefully that makes sense. I will definitely do another problem very similar to this so you can get more practice.